In this video, I'll be talking about the 1,2 and 1,4 reaction. So if we have some kind of diene, and remember diene means two alkenes, so we have two double bonds here, and we react it with some kind of, HCl or some kind of chlorination reaction, depending on the conditions, whether we do it in cold conditions or hot conditions, we're going to get two different products. So if we react it in cold conditions, we're going to get the 1,2 addition, and as you can kind of see, this hydrogen and chlorine were added on the 1 and 2 position. Or if we react it in the hot condition, it's going to give us the 1,4 addition. So as you can kind of see, here's the 1, 2, 3, 4 position. So mechanistically, what happens is all based on the intermediate. So depending on what conditions were given, the intermediate is going to change. So the first step for any of this reaction is to always do some kind of nucleophilic attack. So we have this double bond, and the first thing it's going to do is it's going to attack the hydrogen, like so, right? And we know that the chlorine is going to come off, thus giving us an intermediate that looks like this, right? Keep in mind that this hydrogen was added here, right? And that there's also a positive carbocation here, and now we just have chlorine minus in the solution. So now that we have this intermediate, the next step is to draw resonance. So notice that this double bond can move here, thus producing this resonance structure. So something I want you to notice is the stability of each resonance. So if you remember from your Orgo 1 content, this is a secondary alkene because this double bond is adjacent to 1 and 2 carbons. Conversely, in this resonance, this is only adjacent to 1 carbon. So because of that, this resonance structure is more stable. And I know some of you might be thinking, oh, the carbocation, this is on like a secondary carbocation, whereas this is only on a primary. And while that is true, I think in this case, the stability of the double bond takes precedence. So now that we have these two resonance structure, the last step is to do the attack with the carbon. So remember that on the chlorine, there are, 8 electrons, right? And because of that, it has a negative charge. Thus, it's going to act as a nucleophile. So the last step is for this to attack the positive carbocation, thus resulting in this product like so. Conversely, in this case, this electron is going to attack this positive charge here, thus resulting in this resulting product. So something I want you to keep in mind is that on this carbon, on both of these molecules, there is the hydrogen from the first step, right? And as you can kind of see, this is how this results in the 1,2 versus 1,4 product, because this hydrogen here is on 1 and the chlorine here is on the 2 carbon, whereas here the hydrogen is on the 1 carbon and the chlorine is on the 4 carbon. So when identifying which is the 1,2 versus the 1,4 product, remember that the 1,2 product will always be in low temperatures, aka cold conditions. And the reason for this is because it forms faster. So think about it in this example. If you're cold, you're going to probably want to run faster to enter your house because you're freezing. Conversely, if it's in hot temperatures, right, then it's going to do the 1,4 addition. And the reason for this is because it is more stable. And think about it in this way. If it's during the summertime, you're relaxing, and because of that, you're probably going to be more stable. And lastly, remember that in the cold conditions, it is called the kinetic control, because kinetic means, time or fast. Conversely, high temperatures is called thermodynamic, because it is going to form the more stable product. So as you can see from the previous problem, here is the example of the 1,2 product, whereas this is the 1,4 product. And remember that whether it's 1,2 or 1,4 is totally dependent on whether you're reacting it in cold or hot conditions. So let's do this problem now. Let's say we have this molecule and we do some kind of chlorination reaction, and we do it in both cold and hot conditions. What do you think the following molecule is going to look like? So if we react it under cold condition, remember that any cold conditions is going to give us the 1,2 addition. Right, so it attacks on, the chlorine is going to attack here and here. Conversely, if we do it under the hot conditions, it's going to give us the 1,4 product, because this is the more stable. It's going to give us 1,4. And as you can kind of see, the reason why the 1,4 product is more stable is because this is a tertiary carbon, tertiary double bond. So as you can see, this double bond is adjacent to 1, 2, 3 carbons, whereas this double bond is only adjacent to 1 and 2 carbons. So because of that, this is the more stable product, whereas this is the product that's going to form faster. So mechanistically, the first step is to have one of the double bonds attack the chlorine. So the question becomes, which double bond attacks the chlorine? And the answer is this one. And the reason for this is when this double bond attacks a chlorine, a positive carbocation is going to form here. And we know that tertiary carbocations are more stable than secondary carbocations, which would happen if this double bond were to attack. So if we draw it out, this double bond attacks the chlorine like so, thus resulting in this intermediate structure. So as we can see, the chlorine attacked on this carbon, or the double bond attacked the chlorine, thus adding it to this carbon, and the carbocation forms on the adjacent carbon. So we know that the next step is for some kind of resonance structure to form. So if this electron were to move down here, we were to get a resonance structure that looks like this. Keep in mind, chlorine would be here, the double bond would be here, and now that the positive carbocation would be here. So if we kind of compare these two, which carbocation do you think, which structure do you think would be the more stable one? And the answer is this one. And the reason for this is because, as I mentioned earlier, this double bond is adjacent to 3 carbons, whereas this one is adjacent to only 2. So because of this, this is going to be the more stable product, which, as we know, is going to be thermodynamic, and thus this is going to be under hot conditions. Conversely, because this is the less stable product, we know that this is going to form faster, and because of that, this is going to be formed under cold conditions. So this is kind of how you can identify which one is going to be the hot versus cold conditions. So now the final step is to have the chlorine attack the positive carbocation. So if we have the electrons on chlorine, that is going to basically attack this positive carbocation here, thus forming this structure. Right? And conversely, if the electrons here attack on this carbocation, this is going to end up forming this structure. So if we kind of compare the two, what I mentioned in the last video is, or in the last slide, is that this chlorine is on the 1, 2 position, whereas this is on the 1, 4 position. Moreover, because this is the more stable product, we know this is going to be the hot formation, whereas this is going to be the cold formation. Thus, if we go back to our previous slide, we can see that the 1,4 addition is under high temperature because it is more stable due to the double bond, whereas the 1,2 addition is going to be under the cold condition because it is going to form faster.